Hello, hello. This is a quick stream to show how I can run a load test against a RAG chat application using the Python Locust framework. I was running these load tests anyway, so I thought I would show it. So this is Locust, and it's a nice little framework for running load tests. You can define your load test in a Locust file, and you try to emulate some sort of standard user behavior, like going to the homepage, logging in, viewing the profile, whatever it is that they do on your site. And you can specify, time between things and that sort of thing. And then you can specify how many users you're trying to show. So it's a nice way of testing to see how your app might perform with average load or peak load. So what I want to do is run a load test for this application here. Here is it running locally. So we could do a load test against the local version. Most times you actually want to load test your production version, but it depends on what aspect of your app you're testing. So these apps are interesting because these are ragchat apps, which means they use a retrieval database and an LLM. And so specifically, they use Azure AI Search and Azure OpenAI. So we want to know actually how those are going to withstand the expected load of the users. Of course, we also want to know how our host is going to respond, which in this case is Azure App Service. But honestly, like our hosts are, they can take a lot of, they can generally take a lot of load if we, configure them with the bare minimum of configuration. But we can often run into issues, especially with large language models, which tend to have quotas. So so let's go ahead and load test this. So we could start off with load testing the local one just to make sure that our load test works. So I'll show you, this is my Locust file that I've written for this application. So you can see I just have a single task because it's actually a fairly straightforward app where people are just going to ask questions. So first a user visits the homepage. Then the user spends about 5 seconds on that homepage, and then they post to this chat endpoint, and this is what their post might look like. And we kind of randomly pick different questions, so it's not exactly the same question each time. We also have some other parameters we send in, and then we wait another 5 minutes, and we send a follow-up question as well. So yeah. And then we also have this wait time between 5:20. So that means users will generally wait between 5 to 20 seconds after they complete a task. So this is a nice thing to do because otherwise what's going to happen is you just have a constant spikes of users doing the same thing. So this means that your users, even if you start them all at the same time, there's some variability as to when they, go and do it again. So this setup worked pretty well for me. It's not, perfect, but it seems to work pretty well for emulating user load for these applications. So there's my Locust file, and how I use it is that I run Locust, so pip install Locust, and then run Locust. And what it does is it opens up a local server here, and you specify your parameters for your load test. So for localhost, I'm just going to do kind of bare minimum just to make sure things are that my Locust file is compatible with the application, that it's sending the kind of requests that it expects. So here I'm saying number of users is 5, and the ramp up is how many users start per second. So I almost always do a ramp up of 1, but I increase the number of users as I increasing my what I'm testing in my load test. So then we click Start Swarm, and this will start sending off the request. So we can immediately see that it sends off // and then that immediately makes me want to start over and actually remove the slash. You never know. Some servers are okay with having that extra slash in front of things, but then some servers aren't. So I'm going to start over without that slash. And that's something I always forget. So now you can see it's starting over with the slash. So that's going to the, the front page of the site like this. No, front page looks like this. Here you go. And then it is actually sending a chat request. And so that, will look something like this, right? And then it gets back the response. So here we can see that it It shows how many requests it's sending out. It shows the fails. There's also a nice, pretty chart version of it where you can see this stuff here. And this is fun to watch. Then we can go and look at fails. And here's the thing, for localhost, we do get failures like this, which is connection reset, remote disconnected. I only see this happening with localhost. And when I check the actual logs of the app, I don't see any errors in the logs of the app. So so when I'm testing localhost, I just ignore these ones. And yeah, so it's working with localhost. So now let's try it with the running one. Now, if I keep open this Locust, it does actually kind of retain the charts from before. But I just want to kind of start it over. So I'm just going to take down that Locust server and start it up again, just to start from scratch. Okay, so now we've got it, and we're going to be testing this one. And you can see that it is working. And one thing that I checked before I started the test is I checked my quota for my OpenAI model. So if you go to Azure OpenAI Studio, and you go to your deployments, then you can look at the models you're using. So I'm actually using both the embedding model and the chat model. And actually the embedding model is low. So I should go ahead and increase the quota for that. So to increase the quota, you can go to edit deployment and you can go bam and increase that quota. There we go. You can also, another way of doing this is to go to the quotas tab in Azure OpenAI Studio, and you can see if you've maxed out your quotas. So quotas are per region per model. So I can see that I am now at max for GPT-3.5 Turbo in this region. And then I'm also at max for the ADA model. So I've tried to get as much as I can for the ones that are being used from this app service app. And hopefully that is going to be enough. If not, we will get errors and we'll see. Okay, so then I'll go ahead and put in the host without the URL. And once again, I do like to start small just in case there's some, catastrophic error. We don't want to be like wasting. This is, we're using actual cloud resources here. So this is heading up our actual app service app using our actual Azure, everything from production, right? So, we don't want to just casually do load test because we're hitting up real production resources here. So now let's start the load test here. All right, so we can watch it in chart form. We can watch it in statistics form. I actually tend to prefer watching in statistics form because I'm just waiting to see when the fails come in or if they're going to come in. So far the number of fails is 0, so that's good. So maybe I can go back to chart and watch it increase. So remember that this one we did 5 users with a ramp up of 1 per second. And at this point, we are more than 5 seconds in, so we should have all the users. And you can actually see that down here. This is really cool, the number of users graph. So we can see that it ramped up about 1 per second. We got to 5, and now it has been a constant number of 5 users. But remember that I did put in that that little variable wait time between 5 to 20 seconds. So that means that our users aren't sending those requests at all the exact same times. So this is looking really good. That's good. I like it. So 0 failures. So there's nothing for me to investigate. So I'll stop this one. And then, actually, I don't know what the difference. They recently changed this UI, and I'm not sure the difference between stop and reset. Maybe edit. Okay, I don't know. I'll have to remember what all those things mean. But now I'm going to go to 20 users and ramp up of 1 per second. And is it starting? I feel like I got into a weird state. I'm just going to reload. Okay. Is it going right now? Oh, it looks like it's going. All right. So now we can see it's now at 20 users. Okay. So yeah, it took about 5 seconds to get to 20 users. And we can see what our maximum requests per second is, because a lot of times people will say like, oh, we want to be able to support, X requests per second, right? Which is not necessarily the same as the number of users per second, because most of your users aren't going to be like hitting you up every single second, right? So what I do is usually like, someone says like, okay, we want to support this number of requests per second. And then I figure out like, okay, what's the number of users that I need to bring into the app in order to get to that request per second. That's the way that I do it. So far we're actually seeing 0 failures. We can also look at the response times and make sure that we're not seeing like big spikes. And you can see there's large variability, and that's always going to happen when we're using these large language models, that they can be highly variable in their response times. But we might have some goals for, what our expected latency is. I'm using the pay-as-you-go as your OpenAI versus the provision throughput. So if you're trying to get a guarantee of some amount of latency, then there's this provision throughput where you actually are reserving your capacity. But with pay-as-you-go, like I'm just in the same pool as everyone else. So there's no guarantee of latency. But it's usually been pretty good. This is a GPT-3.5. GPT-3.5 has been fairly performant for me in terms of a reasonable chat experience. Okay, so this is looking really good. We got to an RPS about 3. So let's go higher. So I'll stop this load test, and then I'll say new. And this time, so we did 10, we did 20. Let's go to 50. And we can start thinking about whether we even have the capacity for 50. Okay, so let's look back at quotas. So quotas are in terms of thousands of tokens per minute. Now, when a user sends a request, we can actually look at the thought process here. This is the prompt that goes out. So the final prompt that goes to the LLM has the system prompt, the user question, and then the sources. Altogether, this is about 1,000 tokens on average. Now, when there's conversation history and the user, has past questions in there, then that does increase the token count. So if you do have lots of users that are having long conversations, then you want to consider that in the load testing. I don't think I actually consider that now. But generally we can think, okay, that the average user is going to be about 1,000 tokens in their request. So if we have 50 users and we have 50 users using it in a minute, they're going to use up about 50,000 tokens. Now remember that, so these are tokens per minute, right? And these are in the thousands. So if we have a limit of 270,000 tokens per minute, think of it as 270 questions per minute. And now we usually think in terms of seconds when we're thinking about what we want to support. So if it's 270 questions per minute and we divide that by 60, then it's about 40 users? About 40 users? Let's see. So let's open up our JavaScript console so we can do math and also look at all these errors. But 270 questions over 60 seconds. So we can get about 4.5 questions per second. So the question is, are we going to make it? We do start to see errors here. So I thought we might start seeing errors because I think 50 users is pushing the limit in terms of the current token per minutes we have. And you might say like, well, 50 users isn't actually that much. And that's true. That's why many people do use provision throughput to get more quota, or they use like a load balancing kind of thing, which when you realize that you're over quota on one OpenAI instance, you then use the other one. So there's 2 different solutions. One of them that uses Azure Container Apps, and the other one uses Azure API management. So if we look at these, we can look at the failures, and we see this 500 server error. And that means, there was some sort of issue. And a 500 is usually not good. So I wonder if I should be turning that into a 400 or something, but it really depends on what's going on. So then at this point, I would probably, I might stop it now so that I can start investigating. And then I can also look at usually I take a screenshot and then also look at the statistics and see, okay, so we had 410 requests. Of that, 15 were failures. So this is our failure rate. And yeah, we might also want to look at and see, okay, what was the request per second we got up to? The max was about 5, but at that point we were getting failures. So we were good up until like 4. And then around 5, we started getting failures. So the next step would be to see if we can figure out those failures. So then what I would do is go into my like error monitor. So I'll go ahead and find this, and then go here. And here we can see the failed requests. Great. So I'm hoping that we're just going to be able to see them and immediately see what the issue is. So we see these 500s, and we're going to click on them. Okay, I do see a trace back, which makes me happy. And what do we see here? So there's an HTTP response error. And interestingly, it looks like maybe that one's coming from, oh, here we go, message. Ooh, here we go. Let's see. Operation returned an invalid status partial content. That's really interesting. So I haven't actually seen this this error before. So I will need to dig into it. I was expecting to see maybe a token limit error, but that might be under other exceptions. So we've got 404, we've got local protocol error. I'm still figuring out how to kind of interpret all this way of viewing the data. So this is, we see the invalid status. So those were our 500s. We've got some 404s. So that one's all expected because we don't have authentication enabled. That's fine. 500s are all the partial status. And I need to figure out what how this one works here. We go click on this one. Local protocol error. Can't send data when our state is error. So this might just be a reaction to something that happened earlier. So I need to dig into that more, but that's really interesting. So that's why we do load testing, right? Like sometimes we find out that we've misconfigured our servers. So we need to, go ahead and increase the quotas to the max, whether it's on Azure OpenAI or the search service or even on app service. And then sometimes we just find errors that we hadn't run into before because, we're not constantly hitting it up a bunch. And so then we can look into those errors and figure out if they're going to be issues that might face our users in production and then put in protections for them. So there you go. That is how I load test this RAG chat application. Hope that's helpful for you. Bye.